Hello everyone, welcome back to another kinetic tutoring episode. Today we have another physics problem on friction, so let's get straight into it. A 4,000 kilogram truck is parked on a 15-degree slope. How big is the friction force on the truck? The coefficient of static friction between the tires on the road is 0.90. Alright, so let's draw our free body diagram. Here we have our slope. Here's our truck. There's gravity acting on this truck, and there's also friction parallel to the road that is keeping it from sliding down. All right, so first let's find out the horizontal friction, or the horizontal force that is acting on the truck. And as you can see here, the horizontal component is going to be sine of this 15 degrees times mg. So the mass is 4,000 times gravity. That's going to give you 40,000. And then you multiply that by sine of 15. And then, so let's see what we get there. You get approximately 10,353. 10,353 newtons. And that's the force that is causing the truck to fall downwards. Now let's see. How big is the friction force on the truck? So the friction force is going to be the normal force times mu, which is given to us 0.9. So 0.9 times the normal force. The normal force is going to be equal to the vertical component of gravity, which the gravitational force, which is going to be 40,000 cosine 15. So let's plug that into our calculator and then multiply that by 0.9, which gives you 36,000 times cosine of 15. And here you get that is going to be, hold on, let me make sure I did my calculate. Okay, yes, approximately 34,773. 34,773. So the frictional force is going to be way larger than the force that is trying to get the truck down the ramp. So therefore, we know that the truck is not falling. However, this is not the true friction force on the truck, because it is greater than the force that is pulling the truck down. And if the force was actually this much, the truck would be sliding up the ramp. But as we know from assessing real life situations, the frictional force can only be as great as the force that it is resisting. So therefore, the frictional force is truly going to be 10,353 newtons rather than the value we have calculated here. So there you go. That's really the trick to that problem. And I hope you learned something. If you have any more comments or questions, make sure to leave them down in the comment section below. And I'll see you guys next time.